This is 9.5, irrational numbers. An irrational number is a number that is not rational. It cannot be written as a fraction, where a and b are integers and b is not 0. Rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. The square root of any whole number that is not a perfect square is irrational. Same thing goes for cube roots. If it's not a perfect cube, the cube of it is irrational. So that would be like the square root of 7. It does not repeat and it does not end. Every number can be written as a decimal. Sometimes we have to approximate because they do not end. But they do have decimal approximations. So it does not end, it does not terminate, and it does not repeat. Real numbers are the set of rational and irrational numbers. So I have a little chart here, and we can see real numbers is like everything. Inside of rational numbers, on one side, I have integers, whole numbers, and natural numbers. Natural numbers are like counting on your fingers, 1, 2, 3, 4, and so on. Whole numbers are all of those ones that you count on your fingers and 0. Integers include all the negative whole numbers. And rational numbers is anything else that we can write as a fraction or a decimal that ends or repeats, including all of these whole numbers. Then on the other side we have irrational numbers. Irrational numbers like the cube root of 7. 7 is not a perfect cube, so I know it will be irrational. The number pi is irrational. The number e is irrational. Square root of 2 and the negative square root of 3. Those are just some examples. They are not all the irrational numbers. So we're going to classify each real number. If I have the number, which subset, so which layers does it fit in, and why. The square root of 10 would be irrational because it's not a perfect square. Negative 0.3 repeated, so it's repeated. I know that it is rational, but it's not any kind of whole number because it's a decimal, so it's just going to be rational. I have the negative square root of 25. 25 is a perfect square, and then the negative of that, so negative 5. Negative 5 would fit in the integers. It would be integer and it's rational. So you just have to fit, if it fits in integers, it also fits in all the layers outside of it. To approximate an irrational number, we're going to make a table and keep narrowing in until we get close. So usually we'll be asked to go to the closest tenth or the closest hundredth. So that's 1 decimal point or 2 decimal points after. So we're going to approximate the square root of 90. So I know that 90 is between 81 and 100. Those are two perfect squares. 81 would be square root of 9. The square root of 81 is 9, and the square root of 100 is 10. So it's somewhere between 9 and 10. So somewhere between those. 90 is a little bit closer to 81 than it is to 100. It's only 9 away versus 10 away. So if I say 9.3 and I square that, I get 86.49. If I choose 9.4, I get 88.36. I'm still a little closer. Can I go 9.5 and get closer to 90? That's 90.25. So that's pretty close. That's only 0.25 away, where this was over 1 away. So I'm going to say the square root of 90 is about, that's the squiggly equals, 9.5. To approximate the square root of 10, you can put it on the number line and see what two perfect squares are close. Square root of 10, I know that's really close to the square root of 9. That's only one number away. So 3 is 9. Its square is 9. 4's square is 16. going to be a lot closer to 3 than it is closer to 4, because 10 is a lot closer to 9 than it is to 16. So if I choose 3.3, I get 10.89. 3.2 is 10.24. Let's try 3.1, and I get 9.61. So now I went under. So I'm going to stop here and look. And this is 0.24 away from the number I'm asked, and this is 0.39 away. So 3.2 is the closest number I got there. So I just went to the nearest tenth, but you can go one more decimal place and say, well, what is 3.24? You can narrow in a little closer and be more exact. Now I'm going to compare. That means use less than, greater than, or equal to for the square root of 30 and the cube root of 65. Well, the square root of 30 is going to be more than 5, because 5 times 5 is 25, but less than 6, because 6 squared is 36. So between 5 and 6, probably closer to 5. The cube root of 65, I know 64 is a perfect cube, and the cube root of 64 is 4. So if I put those on a number line, the cube root of 65 is going to be a little bit more than 4, and I already determined the square root of 30 is between 5 and 6, so the square root of 30 is greater than the cube root of 65. Now we are going to approximate the distance between -3,1 and 2, -3. So between 2 points. To do that, I'm going to make a triangle, and I'm going to use the Pythagorean theorem. So if I plot these points here, I have -3,1 and 2, -3. So I want to find what is this orange dotted line. Well, I can make a triangle, a right triangle, and use the Pythagorean theorem. That is -4, because I'm going down, and to the right 5. So if I have 4 squared plus 5 squared is c squared, that's 16 plus 25 is c squared. You could do -4 times -4, that still gives you a positive 16. 16 and 25 is 41, and the square root of 41 is about 6.4.